Question number 106. In most of the terrestrial plants, stomata normally open in the daytime. The immediate cause of the opening of the stomata is: first option, circular orientation of cellulose microfibrils in the guard cells. Second, loss of water from guard cells. Third, an increase in CO2 concentration in the substomatal cavity. Fourth, an increase in the turgidity of the guard cells. In most of the terrestrial plants, stomata normally open in the daytime. Yes, it is true, because in camp plants, the stomata open during the night. They have scotoactive stomata. This opening of stomata is due to, what is the immediate cause of this opening of stomata? Circular orientation of cellulose microfibrils? No, the orientation of cellulose microfibrils is radial in the guard cells, not the circular, and the radial orientation of cellulose microfibrils help in the opening of the stomata. So this statement is incorrect. Loss of water from guard cells. There is loss of water from the guard cells in closing of the stomata, not in the opening of stomata. So this option is also ruled out. Third, an increase in the CO2 concentration in the substomatal cavity. When there is increase in the CO2 concentration in substomatal cavity, then there is a stimulus for the synthesis of ABA, which makes the stomata close. So this option is also ruled out. Fourth, an increase in the turgidity of the guard cells. Yes, when there is increase in the turgidity of guard cells due to endoosmosis, the stomata open. So the correct option for the given question is option number 4. Let's move to the next question. Question number 107. Which of the following elements is absorbed by plants as monovalent cation? First option, magnesium. Second, potassium. Third, iron. Fourth, chlorine. Chlorine is absorbed in the form of chloride ions, and it is an anion, not the cation. Cation has a positive charge, whereas anion has a negative charge. So this option is ruled out. Iron is absorbed in the form of ferrous ions, which has +2 charge. So it is not a monovalent, it is a divalent. So this option is also ruled out. Magnesium is absorbed again in a form of divalent, Mg +2. So this option is also ruled out. Potassium is absorbed in the form of K+, which is a positive monovalent ion. It's a cation. So the correct option for the given question is option number 2. Let's move to the next question. Question number 108. The first step in biological nitrogen fixation is the conversion of: first option, ammonia into nitrites. Second, nitrates into nitrites. Third, nitrogen into ammonia. Fourth, ammonia into nitrates. The very first step in the biological nitrogen fixation, which is carried out by microbes or the nitrogen fixers, is conversion of atmospheric nitrogen into ammonia, or atmospheric N2, which is molecular N2 into NH3. It is the same thing. So the correct option for the given question is option number 3. Let's move to the next question. Question number 109. Select the incorrect statement from the following. First option, nostoc performs oxygenic photosynthesis. Second, during photorespiration, oxygen is first utilized in chloroplast and CO2 is released in mitochondria. Third, in a chloroplast, lumen of thylakoids always have least number of protons during photophosphorylation. Fourth, in the plants like sugarcane and amaranthus, primary CO2 acceptor is phosphoenol pyruvate. You have to choose the incorrect statement from the following. Nostoc is a cyanobacterium and it performs oxygenic photosynthesis. What is oxygenic photosynthesis? A photosynthesis in which oxygen is evolved. So there should be splitting of water. Cyanobacteria perform oxygenic photosynthesis because there is evolution of oxygen, and nostoc, as it is a cyanobacterium, it performs oxygenic photosynthesis. Second, during photorespiration, O2 is first utilized in chloroplast, yes, and then CO2 is released in the mitochondria. Yes, in case of photorespiration, there are 3 cell organelles which are involved. First is chloroplast, second is peroxisome, and the third is mitochondria. These 3 cell organelles help in photorespiration. O2 is utilized in the chloroplast and CO2 is released from the mitochondria. So this is correct. Third, in a chloroplast, lumen of thylakoids always have least number of protons during photophosphorylation. Photophosphorylation is ATP synthesis in presence of light, and during photophosphorylation, lumen of the thylakoids have greater number of protons, a large number of protons, so that ATP synthesis can take place. If lumen has a high concentration of protons, it forms the proton gradient and the protons move from lumen to the stroma to synthesize the ATP. So this is incorrect statement. Fourth, in the plants like sugarcane and amaranthus, primary CO2 acceptor is phosphoenol pyruvate or PEP. It is correct because sugarcane and amaranthus both are C4 plants, and in case of C4 plants, the primary CO2 acceptor is PEP or phosphoenol pyruvate. So the correct option for the given question is option number 3. Let's move to the next question. Question number 110. Match the following columns and select the correct option. You have given some items in the column 1 and some in the column 2. You have to match these items of column 1 to column 2. A is photolysis of water, which is a splitting of water. Splitting of water takes place during the photosynthesis and it is related to the Z scheme or the non-cyclic photophosphorylation. So A goes with second. Hence option number 2 and 4 are ruled out because A matches with second in option number 1 and 3. Now B, carboxylation of RuBP takes place in the Calvin cycle. So B matches with fourth. Option number 3 is also ruled out as B matches with fourth in the first option only. Only ATP synthesis takes place in the cyclic photophosphorylation. In case of non-cyclic photophosphorylation, there is synthesis of ATP as well as NADPH also. So C matches with third, yes, and D, consumption of 5 ATP per CO2 fixed is the requirement in C4 plants. So D matches with the first. How 5 ATP per CO2 fixed? C4 plants has both C3 as well as C4 pathway. In C3 pathway, there are 3 ATP required for 1 CO2 fixation, and in C4 pathway there are 2 ATP. So total 5 ATPs are required to fix a molecule of CO2 in C4 plants. So the correct option for the given question is option number 1. Let's move to the next question.